Okay, so here we are, math 20-1, Unit 4, Rational Expressions and Equations. So this is Finlay, and so it's math 20-1. So we're going to look today at the first lesson, non-permissible values and simplifying. So the first thing is to define rational numbers. Well, rational numbers, as we know, can be expressed in the form a over b. So as a fraction, where a and b are in the set of integers, and b cannot equal 0. You can't have the 0 in the denominator. If you do, it becomes undefined, so it is not a rational number. So this includes a lot of different things. A lot of things, just things we can express as a fraction, and a terminating, oops, I obviously touched something twice, a terminating decimal, also a repeating decimal. So if we have repeating 7, because we can express that as 7 over 9. So, but it has to terminate. If we have a non-repeating, non-terminating decimal, then it is not a rational number. So it's an irrational number. So the example we mostly talk about is pi. Okay, so we're talking about rational numbers, but in this unit, we're talking about rational expressions. So a rational expression is an expression that can be written as the quotient of two polynomials. And quotient basically means it's a division question, which is what a rational number actually is, right? If I look up here, 2 over 3, that's 2 divided by 3, right? So for example, if I have the polynomial 2x plus 3 over 5x plus 4, that's the same as 2x plus 3 divided by 5x plus 4. Or x squared minus 6 over 3xy, that's the same as x squared minus 6 divided by 3xy. So they're basically quotients of two polynomials, right? So the big difference between rational numbers and rational expressions is that in expressions, we're talking about polynomials. So we're going to have variables involved, okay? Now we deal with them a lot, very similarly to fractions. And we also think about our rules for polynomials. So there's some limitations, however. A rational expression cannot contain roots of variables or variables as exponents. So, for example, here we have a variable as an exponent. This would not be a rational expression because we have that x as the exponent. And because we have a radical, a root of a variable, so a root of a variable, right? This would also not be a rational expression, sorry. It is a radical, however. So let's take a look at some of these. Evaluate each expression for the given values. So this is just evaluation. We're going to substitute in. So if my expression is 6 over x and I've got x is equal to 2, I just substitute in 2 for x. So that would be 6 over 2, which equals 3. If x equals 0, that would be 6 over 0, and this would be undefined. And if x equals 1, this would be 6 over 1, which is 6. Okay. Here, a little more complicated for the second example because there are two. There's binomial pairs on the bottom. So, but same thing, we substitute in. So I have 3 over, and I get 2 minus 1, 2 plus 2. So this would equal 3 over 2 minus 1 is 1 times 2 plus 2 is 4, so 1 plus 4, which is equal, oh, and they're multiplied, right? So, sorry, early morning. 1 times 4 is 4, okay? I have a wrong answer in my notebook, so it kind of threw me off. So I'll have to make a note of that. Next one, if x equals to 0, I have 3 over, so 0 minus 1 times 0 plus 2. So negative 1 times 2 is 3 over negative 2 or negative 3 over 2. You can change that to an improper fraction if you want to. And then for the last one, well, here's what happens with this. I get 3 over, I get 1 minus 1 and 1 plus 2. Well, the 1 minus 1 equals 0, so I get 3 over 0, so it'd be undefined, right? Because 0 times 3 is 0, okay? So evaluation, just simple substitution, help you out there, okay? Now, rational expressions are not defined for values of the variables that make the denominator 0. So the first thing we're going to talk about, and very important, is non-permissible values. For example, the expression x plus 5 over x minus 3 is not defined for x minus 3. So x minus 3, or x equals 3, sorry, is a non-permissible value of x plus 5 over x minus 3. The reason for this is, if x equals 3, I get x plus 5. Oh, sorry. Let's substitute it. Well, let's write it all out. Over x minus 3. Well, if x equals 3, this would be 3 plus 5 over 3 minus 3, which would be 8 over 0, which is undefined. So if you make your denominator equal to 0 and rearrange and solve for x, this would be your non-permissible value. This is the number that x cannot be. Okay, we're going to do some examples with those. So, determining non-permissible values. So, all we're doing in this first one is we're determining the non-permissible values. Thing is, we might have to do some factoring to do so. So here, what we do is we take the denominator, x minus 1, make it equal to 0, and we're solving for what we want x not to be. So x equals 1. This is our non-permissible value, okay? Because if x was equal to 1, then we'd get a 0. And we would also, we'd write it as that x cannot equal 1. And that's how we would identify it, okay? Let's do the next one. Now on the next one, we have to factor. So if we factor our denominator, well, let's factor the whole thing. I get x plus 2 over, or x squared plus 2 over on the top. If I factor the bottom, and you're going to be doing a lot of factoring of polynomials, you get two numbers that multiply to give me negative 6 and add up to negative 1. So that is x minus 3, x plus 2. So for the first one, if x is equal to 3, I get a 0. So x cannot equal 3. And for the second one, if x is equal to negative 2, I get a 0. So my non-permissible values are 3 and negative 2. Okay? So basically, I'm looking for the value for x that will give me a 0 in the denominator. Our next one, you might say, oh, I got to factor that, but you can't factor it because x squared plus 1 is not factorable. So x squared is always going to be positive. So we're always going to be able to have a positive value in the denominator. So because, and if you think about that, if you say, well, x squared cannot equal negative 1, well, it never will be. So there are no non-permissible values for this one. Okay. Next one, let's do a little factoring. So on the top, I get x minus 1, x plus 1. And on the bottom, I get, well, two numbers that multiply to give me positive 1 and add up to negative 2. I get x negative 1 times x negative 1. Now, looking at this, for here, x cannot equal 1 because 1 minus 1 would give me 0, and it's the same factor as the other one, so that is my only non-permissible value, okay? Looking at this one, later you can also, when we start evaluating it, you can also factor this out, but you still go back to this step where you have all the factors in the denominators to determine your non-permissible values, okay? So you try the next ones. I'm going to just write the solutions. This is kind of weird. So we want to know if they're equal or equivalent. So this is moving into factoring. So let's take a look here. So are the following rational expressions equal or equivalent? So we have to divide out. We're going to factor and we're going to divide out common factors. So looking at the first one, right away I can divide a 2 out of the top and the bottom. So this expression can be simplified to x plus 1 over x minus 2. And our non-permissible values, we should indicate that x cannot be equal to 2. Okay, now let's look at the next one. I can factor out on the top 2x plus 1 over 2 x minus 2. And then this 2 and that 2 factors out, so I get x plus 1 over x minus 2. And again here, x cannot equal 2. Okay, so this one and this one are looking the same. Now let's do the next one. On the top, I can factor out, sorry, I jumped there. Sorry about that. On the top, this factors two numbers that multiply to give me 2 and add up to 3. So this is x plus 1 times x plus 2 all over. And on the bottom, that's a difference of squares. So it's going to be x plus 2 times x minus 2. And then I can, if I look, do I have any common factors on the top and the bottom? I do. I've got x plus 2 and x plus 2. So this factors out to being x plus 1 over x minus 2. However, for our non-permissible values, I have to go to this step here, this denominator for my non-permissible values. So for this one, x cannot equal -3 or -2, sorry, or +2. So if we look at this answer, they're similar, but they're not completely equal because there are two non-permissible values, not one. Okay, so they do reduce to the same expression. However, there's more limitations on the third one. Okay, so by having those, so this one has 2 non-permissible values, whereas those only have, versus these only having 1 non-permissible value. Okay, so that does make a difference. Okay, let's take a look here. Writing equivalent forms of a rational expression. To write equivalent forms of a rational expression, multiply or divide by the same monomial or binomial. So this is just basically thinking about these binomials or these monomials as factors. Similarly, if you had a 6 on the top and the bottom of a fraction, you know that you can divide out a 6. Well, here if you have the same polynomial expression on the top and the bottom, you can divide that out. So looking here, I have 3 times x plus 2 over x plus 2 times x minus 4. So what I notice is that I have this and this that are the same factors on the top and the bottom. So I can divide them out. And I just divide them out. X plus 2 divided by x plus 2 equals 1. X plus 2 divided by x plus 2 equals 1. So I've divided them out of the top and the bottom. So I'm left with 3 over x minus 4. And then I need to think about my non-permissible values. X cannot equal. I go back to this state to determine my non-permissible values. So x can't equal -2 because that would give me a 0 here. And it can't equal to +4 because that would give me a 0 for that. Okay. Let's try some more. Now, with monomials, it's far simpler to kind of divide them out. We're just kind of simplifying that rational expression, looking for what's common. So if I notice here, I've got an x squared divided by an x. I have a y divided by a y, and a z cubed divided by a z. I also have a 15 and a 20. So I'm going to look for what can I take out of the top and the bottom. Well, the 15 and the 20 are both divisible by 5. So I would have a 3 and a 4 here. So this would equal 3 on the top with a 4 on the bottom. I have x squared divided by x. So x squared divided by x is just going to be an x up top. Y divided by y, well, they'll both divide out. So they disappear. And then z to the 3 divided by z is z to the 2. So I'm basically just looking at what can I get rid of. Now, I do have to look at my non-permissible values. I have an x, y, and a z on the bottom. None of them can equal 0. Okay, so those are my non-permissible values there. Okay, if any one of those is a 0, then the denominator is 0, so they don't work. Moving on. So here, let's do some common factoring first. Oh my goodness, I flipped again. So looking at the top, I can divide out an x out of both of these, and I get 3x minus 8 on the top, and on the bottom I have 2x. So I can divide that x out of the top and the bottom. When I do that, then I get 3x minus 8 all over 2. Now, I still have to look up here. X cannot equal, if I had the only value for which x can't be is 0. Okay. Next one. Again, I'm going to factor the top and the bottom. So on the top, two numbers that multiply to give me 8 and add up to 6. It's x plus 2 times x plus 4 all over, and on the bottom, it's a difference of squares, my favorite. So it's going to be x minus 2 times x plus 2. And then I look for common factors. Well, I have an x plus 2 and an x plus 2 on the top and bottom. So I can divide those out of the top and the bottom. So what am I left with? I'm left with x plus 4 over x minus 2. And then again, I have to look at this step here to figure out my N.P.V.s. Okay, so from that step, x cannot equal 2, because if it was a 2 in the first bracket here, I would get a 0, and it can't equal -2, because if it was a -2 there, I would get 0. One last example here. So let's first divide out, well, no, let's look. How do I want to do this? I'm going to divide out on the top. Well, on the top I have 4 minus x times 4 plus x. It's a difference of squares. Okay. On the bottom, I'm going to have to do decomposition, so you have to remember back to decomposition for that. And when I factor the bottom, I get 2x minus 3 times x minus 4. Now, it's very, very similar, except the signs are reversed. So what I'm going to do is I'm going to divide a minus out of this 4 minus x. Because if I do that, then I get x minus 4. It basically flips the sign. Okay, I can leave my 4 plus x and the other one, it doesn't matter in the order. And then I get 2x minus 3, x minus 4. The reason I did that is because I want a common factor. I want them to look the same. So by dividing out that negative sign, I get the same factor. Because now I have x minus 4 and x minus 4, and I can divide them out of the top and the bottom. When I do that, I get a negative 4 plus x all over 2x minus 3. Now I have to go back to this for my non-permissible values, right? So for this, x cannot equal, with the 2x minus 3, it can't equal positive 3 over 2. If x was 3 over 2, I would get 2 times 3 is 6, divided by 2 is 3, so 3 minus 3 is 0. And it can't equal 4. Okay, so let's put nice little boxes around those because I like boxes for our answers. Now, hopefully that helps with this.